Okay, so factors affecting gravitational force. More things for you to remember, mass and distance. But this time you don't have to worry because, okay, even though yes, you have to remember about mass and distance, but you are given formula. Okay, so factors affecting gravitational force, you can actually see from the formula, not just this one tau. A lot of things, most of the quantities, if they have formula, you can look at the formula to find the factors affecting. So less things to memorize. So F equals to G M1 M2 over R squared. So now you know that F and M1 sorry. So now first we look at the formula. So how to remember which one are the factors? So F is the gravitational force. So you are trying to find factors affecting this. So whatever inside the formula, that should be the factors except for those that are constant. So G, M1, M2, R. So between all of these four values, the one that is constant is actually G. So G is not part of the factors because factors means that you can change them. Okay, you can change, you can increase, decrease, blah, blah, blah. Okay, but gravitational constant is constant itself, so you cannot change. So that is not the factors. So this will leave us with M and R, which is the mass and also the distance. So from here, you already know, okay, that the factors affecting gravitational force are mass and also distance. So from the formula also, you can see how the factors affect the gravitational force. So what I mean is, okay, let's write that one again. Okay, so mass is this one. Okay, so mass is this one. So you can see that from this formula F and M1, M2, they are actually directly proportional. Okay, remember your Newton's upper law of universal law of gravitation though, directly proportional. Okay, so force, gravitational force is directly proportional with the product of two masses. So now, when M increase, F also increase. If M decrease, F also decrease. So distance. So you can see here F and distance, they are actually inversely proportional. So inversely proportional, when R increase, F will decrease. R decrease, F will increase. It makes sense because, for example, we have two objects. Okay, the closer they are, it will make sense for them to have stronger force. The further away they are, it also makes sense that they have a weaker gravitational force. So anyway, these two are the factors affecting gravitational force. So let's see how they can ask, okay, related to factors affecting. Okay, so given the gravitational force between two objects, let's draw here lah. Okay, so the one like not enough space. Okay, let's see, we draw here. This is M1 and then the object here is M2. So the force between them is F, given that the distance is R. So the question stated that state in term of F the force when. Okay, when they say in term of F, meaning your answer should be F with a number. For example, 1F, 2F, 3F, 5F, 0.5F, 1 over 2F, doesn't matter. But your answer should have F. Okay, so when M1 increases to 2M1, what happens to F? Okay, so what they're trying to ask is basically this. You have this set when M1 is M1, when R is R, M2 is M2, and then because of this, you will have F. Okay, but now instead of M1, it is now M2. Double the M1. So meaning you have 2M1. So from M1, it increases to become 2M1. So the question basically asks you what happened to F. Because earlier when it is M1, it is F. So if it is 2M1, what's going to happen to F? Okay, so you know that from the formula F equals to G M1 M2 over R squared, we know that when the M value increase, F also increase. Okay, so now when M1 becomes M2, you know that you have to multiply by 2 because it increased. So we know that F will increase, right? So how to show that F increase, we will multiply by 2 lah. So F multiplied by 2, you will have 2F. So when the mass is M1, the force is F. But if the mass of object 1, M1, is doubled, meaning it becomes 2M1, now your F will be 2F. Okay, so that is the first one. So now let's see what happened if the R becomes 0.1, 0.5 R. So now R change to 0.5 R. So become half. So if we see from the formula here, okay, if you, because F and R is inversely, F and R square is inversely proportional then. So from R becoming 0.5 R, basically you have to divide by 2. But remember, F and R is inversely proportional. So when R decrease, so your F have to increase. So F, you cannot simply divide by 2, because if you divide by 2, it shows that F also decrease. F has to increase. So what you do is actually you multiply lah. Okay, so you will multiply, but then remember the relationship, the inversely proportional is with square. So you have to square also. So from here, you actually get 4F. So when R decreases from R to 0.5 R, you divide by 2. F, you have to multiply 2, but you have to square. So you get 4F. Okay, never mind. Let's change. Let's do another one example. Okay, so let's say lah. R, now you increase, become 3R. Okay, so initially it's R, but now they make it further. Okay, so now it is 3R. It's not accurate, but yeah. So it has increased to become 3R. Okay, so remember R, to become 3R, you have to multiply by 3. So now F, remember when R increase, okay, the F has to decrease. So F, you cannot multiply by 3, because multiply will show that the F value will become bigger. So you have to divide by 3. But then again, square. So square. So now it is F over 9, or 1 over 9 F. So that is how you do the question. Okay, so again, the first one, you don't have to you don't have to square anything. Why? Because the formula, there is no square here. Okay, M is just M. M1, M2 is just M1, M2. Okay, but R is the one that you have squared. Okay, so that is why when you do calculation related to R, the F also, you have to include square. So that is the factors affecting gravitational force.